Okay, so today we are going to finish up the notes we started on confidence intervals. Okay, so we left off here on this page where we had filled in that our estimate error amount is fairly typical. Okay, so we're going to continue on from there. And so there should be a way to report both our estimate and how far off this estimate might be. And one way to do that is by using or doing it with a confidence interval. Okay, so that's what we're going to fill in that spot right there. Okay, now we're going to go ahead and flip to the next page. All right, so on the next page, what we're going to do is we're going to use data from Spain, which has the best records for EU migrants, both documented and undocumented. Okay, remember EU is just European Union. Okay, so according to a report in Comparative Migration Studies, Spain has a nationwide rolling local population register, which provides a comprehensive register of the population, also including unauthorized immigrants. The Immigrant Citizens Survey conducted a random sample of this data, surveying recent immigrants to Spain who were 15 and older. Okay, so we're actually going to use some real data at the end. Okay, but right now we're going to use some mock data. Okay, so our mock data we're going to use, and remember this is mock data. We'll get to the real data in a bit. Okay, we're going to use this mock data. So it says, in reality, we don't know the true proportion of recent immigrants to Madrid, okay, who are male, because it's almost impossible to collect records about each individual. So instead, imagine we surveyed a random sample of 34 immigrants. So this is going to be our mock data. 34 immigrants in Madrid's address registries. Of the random sample, 15 identified as male. Okay, it says estimate the true proportion of Madrid's recent immigrants to identify as male with 95% confidence. Okay, so we're going to use this as our proportion. We're going to put 15 up here in the numerator. We're going to put 34 down here in the denominator. We're going to go ahead and divide, and we get our proportion here. I'm just taking it out to 3 decimals, is 0.441. Okay, so that is our proportion that we're going to use. Okay. All right. So now, what we're going to do to figure out our standard deviation, or what we are also calling our standard error, is we're going to remember we can use that formula that we wrote down from the very beginning. Okay. And so we can use the formula that our for our normal distribution, that our mean is going to be p hat, which we already found here, right? Okay, and our standard error for p hat is going to be this formula that we wrote down on the previous page in the beginning. So it's going to be p hat times 1 minus p hat, okay, divided by n. All right, so if I start plugging in things here, okay, so I know this one was 0.441. Okay. And then here, when I plug into this, I'm going to get that this is the square root of 0.441 times 1 minus 0.441, okay, divided by 34. Because n is my number of people that I sampled, and my n value was 34, right? Okay, so I'm going to go ahead and solve this, okay, and I'm going to round that to, I'll take it out 3 decimals, and so when I do that, I get 0.085, okay? So this is my p hat, right, or my mean. This is my standard error, okay? And so my standard error is, it's just like a standard deviation, right? It's the distance that I'm going to go out on either side to get to this 95%. But remember, this is 2 standard errors each direction. So 2 standard errors this way, 2 standard errors this way will give me that 95%, okay? So what I'm gonna do to find my confidence interval is I'm gonna use the formula that I wrote down from the beginning. If you guys remember, it was this formula right here on the very front page. P hat plus or minus 2 standard errors of P hat, right? So the standard error of P hat is 0.085. So I'm gonna do using this formula. Okay, so the standard error of P hat is 0.085. P hat itself is 0.441. So I'm going to go ahead and do 0.441 plus 2 times 0.085. Okay, that's the plus part of this. And then I'm also going to do 0.441 minus 2 times 0.085. Okay, so when I go ahead and do that, okay, I'll just get my calculator. 2 times 0.085 is giving me 0.17 plus 0.441. So this is giving me 0.611. Okay, so that's going this direction. Okay, so that's why we have this marked out right here. Okay, and this other one, okay, is 2 times 0.085. Okay, it's a negative, so let's make it negative and then add to it 0.441. Okay, so I get 0.271. So that's going in this direction, this way. That is our like boundary line, I guess you could say, for this side. Okay, so I know that my confidence interval is going to be between these two numbers. Okay, so my confidence interval, we could say, is between 0.271 and between 0.611. So this is my confidence interval. Okay, it's between those two values. Okay, that's 2 standard errors this way. That's 2 standard errors this way from the mean, which was P hat. Okay, now what we say, our interpretation, what we say is we say we are 95% confident the interval from, I'll write these as a percent, 27.1% to 60.8% captures the true proportion of Madrid immigrants who are male. Okay, so what this is telling me is I can be 95% confident that this interval is capturing the true proportion of immigrants that are male. So the proportion of immigrants that are male, I'm saying here, I'm 95% confident that it is somewhere between 27% and 60%. Okay, that's what we're saying here, is that we're 95% confident that the true actual proportion is somewhere between here. That's somewhere between 27 to 60% are actually males. Okay, now let's go ahead and turn to the next page. Okay, all right, so, okay, on the next page, okay, here we have basically the same problem that we just did. Okay, and so what we want to think about is we want to think about like this being basically a 4-step process. Okay, so in the 4-step process, when you're doing these confidence intervals, the first thing you want to do is you want to state the parameter that you're estimating and the confidence level that you're trying to estimate. Then you want to plan. So name like your inference method or what conditions you are checking. Then you're going to do the calculations. Okay, and then you're going to conclude, which is interpret your result. Okay, so for the state part, we are estimating, in this last problem we did, the true proportion of Madrid's immigrants who identify as male. And we're estimating this, remember, at what confidence level? at 95% confidence. Okay, so my plan here is that I'm going to calculate P and also the standard error. And the standard error of P hat, okay? And the conditions that need to be met, and we didn't quite talk about this yet, and there's 3 conditions that need to be met in order to be able to do this, okay? So I think we might have briefly touched on this in the beginning the other day, but we didn't talk about this again yet in the video. Okay, but remember we talked about these 3 conditions. The randomization condition, meaning that the sample needs to be independent, the 10% condition, and then the success failure condition. All of these conditions need to be met. So I'm going to show here that they are going to be met. Okay, so one is that it's random. Okay, and we were told in our information that the sample was random. So as long as you're told the sample is random, that condition is met. Okay, the 10% condition, okay, which says that our sample is less than or equal to 0.10% of the total population. Now, we don't actually know the entire total population of immigrants that are coming in, okay, but if we think about this, okay, and we just solve here for n, okay, and I divide, right, this is saying that that in order for this condition to be met, that this number needs to be larger than 340. And that is a reasonable assumption to make. It's reasonable to assume that there's at least more than 340 people immigrating into Spain. So we're going to say that this checks out that yes, it is reasonable to assume at least 340 people are migrating to Spain. And actually there's like tens of thousands of people immigrating. So so this is like very, very much under, okay? Like to put it in perspective for you guys, like thousands and thousands of people, okay? All right, and then the last one, which is the success failure condition. Okay, I'm just gonna abbreviate that. Okay, that one is n times p hat must be greater than or equal to 10. Okay, so that's 34 times 0.441 has to be greater than or equal to 10. Okay, which ends up giving us 15 is greater than or equal to 10. So that one checks out. The other one is n times 1 minus p hat is greater than or equal to 10. Okay, so this is going to be 34 times 1 minus p hat is, let's see, 1 minus 0.441 is 0.559. So we're going to multiply that, okay, times 34 is about 19, okay? So 19 is greater than or equal to 10 as well. So both of these ones check out. So that condition is being met, okay? So I need to make sure that these conditions are met in our planning stage, okay? Then our calculate stage, or our do stage rather, is where I'm gonna do my calculations. And we already did our calculations on the other page, okay? So I'm just gonna say see previous for this. Okay, and the last is conclude. Okay, so for conclude, we're going to go ahead and we're going to interpret our interval. Okay, and so for the conclude portion, we wrote this on the other page, but we can rewrite it again. We are 95% confident, the interval from, and what were our numbers we came up with? 27.1 to 60.8. Captures the true proportion. I'm going to abbreviate that. Of, let me reword this, immigrants that are male. Okay. So this is our 4-step process here, okay, including the calculations, which I didn't rewrite, but they are on the previous page, okay. Now, it says use your interval to evaluate the validity of Trump-Farage's claim that 60% of migrants are male, okay. So with this scenario that we came up with a range of 27.1 to 60.8. So their 60% number, their claim they're making, it is possible, okay, that because it is in our confidence interval, okay? So we would say here that because the claim proportion, which theirs was 60%, is inside the confidence interval, the claim is plausible. Okay, so we don't have any like sufficient or enough evidence to actually reject the claim because their claim is actually within our interval we came up with. Okay, if they were claiming 65% or 70%, we would say that we don't have enough evidence to support that claim being plausible, but right now it is plausible because it is inside of our range. Okay, all right, so now remember this problem that we did, this was based off of the kind of mock data that we had. So let's go on and let's now take a look at redoing this. So we're going to go a second time redoing this using the real data. Okay. So the real data was is given here. Researchers randomly selected 583 Madrid immigrants and 257 were male. So here's your proportion. Your p hat is 257 divided by 583 at 44%. So we're getting the same percentage here. Now our sample value is different. We have 583 total. Okay, so let's go ahead and take a look at what would be happening here. So this is the same sample proportion as before, but we have a much higher sample size. So is the Trump-Farage claim 60% still plausible? Explain why or why not, okay? So we're gonna go through this one and we're gonna check, okay? So we're still estimating the same thing. We're still trying to estimate the true proportion of Madrid's recent immigrants to identify as male at 95% confidence, okay? We still need to make sure that we're satisfying all 3 conditions, okay? So number 1, was it random? Yes, okay, so the random condition checks out, okay? Number 2, if I do this 10% condition, okay, we are having 583 for our value there. Okay, so I'm going to divide and see if this seems reasonable. And remember, I told you guys like there were tens of thousands of people immigrating. So this is giving me that I have 5,830 is less than the total number of immigrants, which I think is reasonable because there were like tens of thousands of people immigrating. So I'm going to say that yes, this is reasonable, okay? And then the last condition was n times p hat is greater than or equal to 10, okay? So we're gonna go ahead and do 583 times our p hat is 0.44. It's greater than or equal to 10. Make sure that checks out. Obviously, it's going to check out, but we'll just do it just for the practice of it. Okay, so I'm getting 256.52. That's definitely greater than or equal to 10. Okay, and then we have n times 1 minus p hat is greater than or equal to 10. Okay, so when I go ahead and do that, okay, I'm getting 583 times 0.56 should be greater than or equal to 10. I'm going to go ahead and multiply, and it's definitely greater than 10, 326.48. Okay, so this one checks out also. So both of these are checking out for the success failure condition. Okay, so we've got that it is random. We've got our 10% condition. This one checks out. And then we've got our success failure condition. This one checks out too. Okay, so all of that, all those conditions are met. Okay, so what we want to do right now is we want to go ahead and do our calculate. Okay, so for our calculation, we already have p hat, right? We just need to go ahead and we need to use our formula that we used before to find our standard error first, okay? So to find our standard error of p hat is going to be the square root of p hat, which was 0.44 times 1 minus 0.44 divided by our n value in this case was 583. Okay, so let's go ahead and figure out what that is. Okay, so 0.44 times 0.56 divided by 583. And then I'm going to square root that. Okay, I'm going to take this out to about, let's see, I want to do 4 decimals. Yeah, I'll go ahead and do 4 decimals, okay? So if I go out to 4 decimal places, this is 0.206 after I do some rounding, okay? Now, remember, we're going to use our formula to find our, we want to find our confidence interval. And remember, our formula that we had was, for our confidence interval, we're going to use p hat plus or minus 2 standard errors of p hat. Okay, and that's going to give us our interval. Okay, so now we're going to go ahead and we're going to do 0.44 plus 2 times, my standard error is 0.0206. Okay, we're going to see what that top end looks like, and then we're going to do 0.44 minus 2 times 0.0206 and see what the bottom end looks like. Okay, so 2 times 0.0206, okay, plus 0.44 is giving me 0.4812, okay. For the other one, okay, I'm getting 0.3988. Okay, so here's my confidence interval. My confidence interval is from 0.3988 to 0.4812. So this is my confidence interval here, the low end, the high end. Okay, so I'm going to go ahead and I'm going to do my last part, which is I've already, done the calculations. Now I can actually conclude or interpret. Okay, so for my conclusion, we're going to say that we are 95% confident the interval from, and I'm going to write these as percents, 39.88% to 48.12% captures the true proportion of Madrid immigrants who are male. Okay, So now it's asking me up here, okay, is the Trump-Farage claim of 60% of all immigrants are male still plausible? Okay, so based on this actual data, not our mock data anymore, but this actual data, is the Trump-Farage claim still plausible? And so our answer here is, well, first look at, is their claim 60%, is that within our confidence interval? No, it's not, okay? So the answer here is going to be the Trump-Farage claim and remember their claim was 60% male, is outside of our confidence interval. So it is not plausible, not a plausible claim given the data that we have collected. Okay. All right, so that will be it for the notes. Make sure that you have those all written down, and then you're going to submit the notes, and that's it.